All right, thank you, everyone. So our next presenter comes from our sponsor, Panasas, Sven Neirynck.
I'm Sven Neirynck from Panasas. You can reach me at sven@panasas.com, which is much easier than using my last name. So what is Panasas? Panasas, we're making a parallel file system. We've been in the industry for over 20 years, almost 25 years now. The company was founded by Dr. Gard Gibson. Dr. Gard Gibson was one of the co-authors of the original RAID paper. I like to call him like the godfather of RAID. Without Gard Gibson, we wouldn't have any storage industry. We have over 600 customers, and recently we had a complete new management team. Our new CEO, Ken Cleffy, comes from Seagate recently. We did a lot of investment in R&D. Just the last 6 months, we have hired a bunch of new people, a lot of experience inside the company. The key point of Panasas is we are a parallel file system for HPC, but it's reliable and easy of use. This was the main key points when Gard Gibson founded the company. He wanted something that's easy to use, easy to manage, not something complicated. Some numbers. We have measured the reliability of the Panasas file system, and we are over 99.9% availability. And this is a real-life availability as measured by customers reporting incidents of downtimes. Typically, a Panasas storage only requires half an admin to manage it, and now we're talking about multi-petabyte deployments. Typically, we also install a Panasas system in less than a day. Some caveat, depending on the amount of racks, the hardware installation alone can take some days, but just the configuration setting up is in a day. Everything is set up, and you have access to the Panasas file system on your Linux compute cluster. So what are the key points of Panasas? It's HPC, it's scalable performance. We scale linearly by adding OSD storage devices. We are optimized for HPC. It's also, in the old days, big data, AI workloads. We do it all. But as I already said, the main point is the easy button. It needs to be easy to use, easy to manage, easy to set up. Not a lot of tuning, not a lot of tweaking. It just works out of the box. We have enterprise liability. We have a patented file-based erasure coding, and that also falls back into the uptime numbers we can give. It's a reliable enterprise-grade system. Dedicated support organization. Panasas, the only thing we do is our Panasas file system. We deliver it to you as an appliance, so we combine the hardware and the software, and we have a support team that they just do Panasas. When you call Panasas for support, the people, they know about Panasas, they can help you immediately. One of the things that we are unique in is that we are looking at the hyperscalers, and we can leverage the technology that the hyperscalers are using. We have seen from the keynotes today that hyperscalers and AI are driving the hardware, the interconnects, everything. We also see that in storage. The Seagates of the world, they're making dual actuator drives for the hyperscalers. The Hammer drives, which are using heat assistant, they're all designed for hyperscalers. And the key differentiator there is that they only have a single SAS port or single SATA port. So not everybody can use those devices. So how does a Panasas file system works? So on the hardware side, we deliver you 2 types of nodes. We have storage nodes and director nodes. Storage nodes is where the data resides on. They're hybrid devices. They have a combination of hard drives, NVMe SSDs. The director nodes are more the brain of a Panasas file system. The director nodes will handle the Panasas cluster. They will do the changes on the Panasas cluster. They will handle the user interfaces, both CLI and GUI. The director nodes will also reconstruct data in case of failure. The director nodes will handle the metadata of the Panasas file system. We will partition the file system, and then each partition, the metadata will be handled by a separate director node. So we are scalable in metadata performance. And also the director nodes, they will re-export the complete Panasas file system over NFS, CIFS, and even S3, so you can access the same files from your compute cluster, but also NFS or CIFS. The main access to a Panasas file system comes from your Linux compute cluster. We will install a Linux kernel module, a directional client, which implements our file system. And when a Linux node then wants to access a Panasas file, it's first going to contact the director node, which are handling the metadata of that file. The director node is going to check permissions and going to give back to that Linux node a layout, a map of the file, where are the pieces of that file. And with that information, the Linux node will then contact all the storage nodes which have pieces of that data to retrieve the data in parallel. There you can see by adding more storage nodes on the network, you're not only adding more capacity, you're also adding more performance. When a Linux node wants to write a file, the same thing happens. It's going to contact the metadata manager of that file. The director node is going to check permissions and going to give back to the Linux node a map where do you need to write a file, a capability, are you allowed to write that file? And with that information, the Linux client can then write the file. How will the Linux client do that? It will chop the file into pieces. It is the Linux client who's going to add the parities to that file, and then each object, each data, and the parity will be written to a different OSD, to a different storage device. So in the Panasas file system, the parity, the erasure coding, is calculated from inside the Linux client, inside your compute cluster. This has a lot of advantages. This means that your data is protected from the moment it leaves your server, even from within the Linux node. If you have a bad network card, if you have something in the network, your data is already protected. So this means the data, when it arrives on the storage nodes, is already protected. That means that our storage nodes can be simpler. If a storage node fails, we can reconstruct the data from the other storage nodes. So we don't need complicated mechanisms like HA between the storage nodes, redundant RAID controllers. We don't need that. A storage node is like a simple Linux server with a local file system. If that fails, we can just reconstruct the data. The erasure coding in the Linux client is on a per file basis. This means that in a Panasas system, you can have in the same directory different files next to each other with different erasure coding. By default, the Panasas system will use a 9+2 layout for large files, and small files will be mirrored with 3 copies. This is perfect because you don't want small files in a RAID 6 layout for the read-write overhead when writing those files. The director nodes, they are handling the state of the Panasas cluster, and we have multiple director nodes. In a minimum Panasas configuration, we have a minimum of 3 director nodes. The reason for 3 is we're using a Paxos algorithm to get the state of the Panasas system. And the Paxos algorithm, you need to have a majority alive to be redundant. You can have either 3 or 5 configured in a Paxos, what you call a rep set for the management of the Panasas system. We can have more than 5 director nodes, and those extra director nodes, they will handle more metadata, they will handle more performance for NFS, and they will have more reconstruction performance. The storage nodes we're shipping today typically have 6 hard drives and 2 SSDs and NVMe inside. So they're small boxes compared to other setups. So as I said, Garth Gibson, who was the co-author of RAID, RAID is like using lots of drives as one big drive, but those drives can fail. You have RAID to reconstruct. In Panasas, we have done the same thing with the storage nodes. We have a lot of storage nodes, but they are redundant or inexpensive. They can fail, and we can reconstruct the data. This is like the next layer. Beside the Panasas file system, we have additional functionality. We have Pan Move and Pan View. Pan Move lets you manage data, like moving data around, backupping data, archiving data. and not only from Panasas or to Panasas, but also from Panasas to an S3 to any other POSIX file system and vice versa. So the hardware we're currently shipping for the Panasas file system. So as I said, Panasas is delivered as an appliance. We're delivering you both the hardware and the software combined. The Ultra model, we have 3 different types of it. We have Ultra Balanced, Ultra Performance, Ultra Capacity. Ultra Balanced consists of 3 director nodes. You can also have 4 director nodes in a single enclosure, and then a minimum of 3 OSD enclosures, storage enclosures, with a minimum of 12 nodes in total. As I said, typically 6 SATA hard drives, 2 SSDs. Capacity on a per rack base is a little shy of 5 petabytes in a rack. The performance we're getting out of a ultra balanced system is around 160 megabytes per drive. The numbers per rack are then about 32 gigabytes. You will also see that our write speed is a little bit higher than our read speed, which is also not much seen in the industry. Normally we see the other way around. In the performance rack, we are using the dual actuator drives. The dual actuator drives are like normal drives, but instead of 1 read arm, they have 2 read-write arms, meaning that they almost double the performance. The capacity of those drives that are shipping today are 18 terabytes. So in a full rack with dual actuator drives, today we have around 3.5 petabytes raw. The performance is higher than the single actuator drives, and we're seeing in a full rack over 50 gigabytes per second performance. And this is performance just coming from the drives. So in the Panasas system, we are writing large files to the drives, small files to the SSDs. The last version of Ultra we have is the capacity version, which is a lower cost version of the balanced one. It has less SSD space. It has 12 drives per node. And the way we do it, we have almost the same node as a balanced one, but we're adding a JBOD with another set of 6 drives. Performance is a little lower per drive because of the overhead of the JBOD. We're getting around 27 gigabytes per second per rack. Those are the slides I had prepared. It's a little bit short of the 30 minutes I have in my time, so I'm open for more technical questions, either now or later.
Any questions for Sven?
Thank you for your speech. Is there any downtime if you want to increase your capacity with those 3 different flavors you mentioned?
Yeah. So in a Panasas file system, so when you can add storage nodes, you can add storage nodes online while the system is online. The new storage nodes will automatically integrate into the Panasas system. You can then just add them to your storage pool, all of that online. And the system will, in the background, migrate data from the full nodes, your initial nodes, to the new nodes you have put into your system. So you're going to get even performance increase from your existing files. And this is all online. Thank you for the question.
Any other questions?
Hi, thank you. Can you say what kind of, if you are working on interfaces for integrating these type of solutions with new tools like the ones that we get from Kubernetes in order to instantiate these capabilities on those platforms?
I didn't understand the question. What do you mean by new tools?
So, for instance, to make available some of these resources within platform orchestrator like Kubernetes.
Yes. So in the Panasas system, so what we're doing is the global Panasas system. You have one like, you make a big storage pool of all your OSDs. In those OSDs, you create volumes. Volumes are lightweight. There's just like a directory under the slash of your file system, even a few levels deeper. And then the volume is really the entity which you can then put into your tools. You can then say, okay, this volume is available on those nodes. A volume is also the unit for snapshots, so you can create snapshots of a volume. In a Panasas file system, so when we have a failure, the system will reconstruct the data. The rate layout in the Panasas file system is on a per file basis. So each file has its own rate layout. This meaning that when we are reconstructing, we're going to read from all the drives into the storage pool and write to all the storage pools.
Sven, I need to interrupt you, sorry. So
no problem.
I believe Felipe is talking about these modules that allows you to talk to Kubernetes. And here, like, for instance, CSI.
CSI, okay, CSI
and tools like that will be able to give you direct access.
Yes. So the CSI plugin, we don't have it today. It's on the roadmap. So the automatic provision from a volume, it's the same thing. It's just creating the volume. But the automatic plugin for CSI for Kubernetes is today not available. But it's easy. It's easy to script to create a volume. So it's not that hard to do.
So that would be good that you should have it, I believe. It's not hard. So could you please give us a state about the other modules that you offer? Because if I understand well, you can give access S3?
Yes. So the native protocol is the flow. So your Linux compute cluster is using the flow, which is a parallel protocol to access the data. The same files will be accessible over NFS, SMB, and S3. For NFS and SMB, there we have the full user mapping and ACLs and access control list. For S3, as we all know, the access to S3 is like kind of different. So there you might have issues of how do you say that this person has access to an S3 object, yes or no. This might be complicated. But for the rest, we have the full S3 protocol. So you can, any program that can access an S3 can also access the Panasas. The other way is if you want to write to an S3, then we have the other product, which Pan Move. Then which Pan Move, we can take whatever you have on any file system and then move it to an S3, which is the other way around.
Thank you.
Any other questions? All right, thank you, Sven.